A new set of notes right here. We're going to do section 5.4, more trigonometric graphs. So we're going to just do the graphs of everything else now. Alright, so we're going to talk about tangent and cotangent. So tangent and cotangent each have a period of pi. And, oops, this should not read that. I'll have to fix that note. Let's go ahead and fix it on yours as well. It should read tangent there. So t plus pi would just give you back tangent of t. Cotangent plus pi gives you back just cotangent. Secant and cosecant, since they're just 1 over cosine and then 1 over sine respectively, each of these have a period of pi. Since these also have a period of 2 pi, since these also have a period of 2 pi. All right, so let's talk about the graph. So here, remember, tangent's the same thing as the sine of x over the cosine of x. And so when we have 0, we have asymptotic behavior, and these occur at negative pi over 2 and then pi over 2. And so here we have our pi over 2 plus pi over 2 gives us our 1 pi period. It is 0 at 0 because cosine is 0 and sine is 0. And then here sine is 0. That means this gives it the asymptotic behavior. That's why it's not defined at these points. So it's not defined at negative pi over 2 and pi over 2. And then it just comes in and looks like this. And you can actually fill in these spots if you like at pi over 2 and all this other stuff. But this is the behavior, and then it just repeats itself over and over and over again. Cotangent is the ratio of, so it's 1 over tangent x, and there's a couple other ways to do this. So and this is just a flip, so here if we come here to pi, we can chop in our little asymptote, and then it just comes in, and then here at 2 pi, or pi over 2, so the inverse of the dividing by 0 will give you this. It would just be 0 on top, and it comes in and goes down. And then this also just repeats over and over again for all this. And so here you can graph these things. For secant, secant is 1 over cosine of x. And so here, if we just draw in here, we just choose green. We'll draw in one period. So here we'll have pi, here we'll have 2 pi. And then here we can just draw in our cosine. So it comes in. Oops, put in my half marks. Put in my half marks so that'll make it easier. This is 1 and minus 1. So it comes in, goes down, comes up, right here. And so here's my 1 period. And therefore the secant will just be the inverse of that, and so here it comes, when it's at 0, of course, we'll have asymptotic behavior. And so it comes in, goes up, and so here it goes up like this, and then it comes in, comes down, and then here it comes up like that. And it actually comes in, it should touch the 1. And then this just repeats for every 2 pi. We'll do the same thing here with cosecant. Cosecant is 1 over 1 over sine of x. So let's draw sine of x in green. So here we'll have pi, here we'll have 2 pi. We'll have 1 and minus 1. And then we'll put in and then here we'll put in our half marks. And so it comes up, comes back down, goes through, comes back up. And then for here, go ahead and do this in blue. And so here it gives asymptotic behavior here at 1, and here again at 0, and then here at 0. And then here we just have it come in and touch and come back out, and then come in and touch and go back out. All right, let's go to the next page. All right, so we can do transformations of tangent and cotangent using the same thing we did before, where k is greater than 0. We're using vertical stretching, of A, and so it's not the amplitude but how much you vertically stretch in a period of pi over k. Since the period is pi over k will give us a new period, and our phase shift is B. Remember, our phase shift moves the 0 around, and so we'll do this slowly with you. Alright, so the first thing we want to do is graph tangent of 2x. So tangent of 2x, it just looks a lot like tangent, except now the period is, so everything's the same except for the period. So the period is pi over 2. So pi over k, where k here is 2, and so we have pi over 2. And so that means it only takes 2 pi over 4, so half of pi over 2 and minus pi over 4, to run through this thing. So we're just going to draw our asymptotic lines. And then it'll come in, go through at 0, come back up, and then it repeats itself. Then it'll repeat itself, so you can draw more than one if you want. Here, we're going to do the same thing again, but now we're going to move it over pi over 4. So here, our period once again is pi over 2, because it's pi over k, and k here is 2. We're going to move it to the right by minus pi over 4. So here we're going to take the 0, we're going to move that over to here. So our 0 point is pi over 4. And then since we have a period of pi over 2, we're going to do half of that forward. So half of pi over 2 forward would be pi over 4 plus pi over 4, which gives us pi over 2. Half of this period backwards will give us, of course, 0. So here are two asymptotes. And then we can go ahead and graph this in. And then I'll just do 1 for this one. But it would repeat. It would repeat on both sides. Let me actually extend 1 out just to another one. So the next one would be 3 pi over 4. Let me do it very directly once, and then so that's half of the period, and another half of the period, of course, would just be pi. And then here we can just draw in the next set. And so onward and upward. Here, let's do cotangent. Alright. So cotangent, so minus cotangent. So notice the normal cotangent comes down, looks like this. So minus the cotangent. So here, let's just put, so here's pi. So our normal cotangent looks like this. And it comes through at pi over 2. So minus the cotangent would just be the opposite of that. And here's my asymptote. And so it'd come up, go in, and then pop back out. Okay, so this is minus the cotangent. And this would be, of course, this would be an asymptote. So this negative sign means just flip it across the x-axis. Here we're going to have 2 cotangent of 3x divided by 2. Alright, in order to do this, remember you do need to pull out this k, so let's have it as 2 cotangent of 3x minus pi over 6 now. Okay, so now we're going to take our 0 and we're going to move it over by pi over 6. So our 0 was up here, so we're going to have our first one at pi over 6. So here it is, pi over 6. So pi divided by 3 is our period, because remember, the same for tangent, same as cosine is pi over 3. So I'm going to move pi over 3 this way. Or pi over 6 this way, and pi over 6 this way. Hold on, we're doing cotangent. So tangent, we go halfway. For cotangent, you're just going to move pi over 6 this way, or just move pi over 3 this way. So this will be pi over 3, which is my halfway point, and then I'll have pi over 2, which is 2 pi over 6 added to this. And then here we'll have our vertical line. Be very clear about this. And then it comes in, goes down, and goes like that. Actually, it comes with a little bit more of a curve. There we go. And then if we say, let's just draw another one this way, so pi over 6 this way would be our 0, and then another pi over 6 this way would be pi over or minus pi over 6, and then here we go like this, and then here it comes in, goes down, oops, so it comes in, goes in, goes down. And so that's how you move and transform these graphs. So make sure you have it in, one thing to be very clear about is make sure you have it in this form, right? If it's not in this form, get it in this form, that way you can clearly just say what your pi is. Remember your phase shift moves over your 0 point, so your 0 moves left to right according to the phase shift. And then you have your vertical stretching. Here this 2 means it's just stretched a little bit longer along this axis. It's really hard to tell. But you just, if it was 1 here, you'd move it up 2. If it was 2 here, you move it up to 4 and such. We were so careful when drawing this exactly. And then let's do some stuff with secant and cosecant. So here we have the graph, transformational graph of secant and cosecant. So here's the same thing for, we have vertical stretching of A. We have a period of pi over, oops, this should be 2 pi over k. Sorry, there's two errors in this set of notes. This should be 2 pi over k. I will fix them for next time. So one of the bad parts of not having, of me making all these brushes not all of them exact the first time. So this should be 2 pi over k, and a phase shift to B. All right, so let's just do minus secant. So in minus secant is everywhere I see a secant, I just flip it upside down. So let's go ahead and do that. And so let's go ahead and draw our secant in. Alright, so secant is 1 over cosine of x. Cosine of x is 1, but this time we're going to be flipping it upside down. So let me draw secant in green. Let me just draw the secant of x in green. So here we'd go over, here we'd go over to pi over 2, and then we'd have pi, and then we'll go the other direction, and we'll just do minus pi over 2, and then minus pi. Alright, so secant, normal secant looks like this, and then it comes in, then it has, from here it'd be 1, and then come back in, and then from here it is 1, and then it comes back in, and these are my asymptotic lines. I'm just drawing the period from negative pi to pi just to fit on this graph a little bit better. When you're doing it on the computer system, it'll have it on whatever system way it has. So that's what that is. So negative would just mean flip this over the x-axis. And so here at minus 1 instead of 1, right, I'll have it look like this, and then this will come into 1, and then this will come into 1. So you just flip it upside down. Alright, let's do another one. Let's do this one. So let's do 3 secant of pi over 2x. So let's do this. So pi over, yeah, let's go ahead and do this. So here we have this, and so let's look at what gee, I didn't change these at all. Sorry about this, guys. This should be secant, and this should be cosecant. Cosecant is CSC. Okay, so notice here, we want it in this form. We do, so we have k here is pi over 2. So k is pi over 2, so, or 2 pi over k, well here it's pi over 2, so if I did this, these cancel, this flips up top, and so I just get 4. 4 is my period, right? 4 is my period. And so here, let's just go ahead and do secant again from, we'll go ahead and go forward and backwards too, okay? So here, half of that would be this, and so my period here would be 1 of 4, so we see the whole thing. And so here we're just going to draw it in. So halfway, of course, would be negative 1 and 1. Here we're going to have, so it's 3. And so everywhere I see 1, I'm actually going to move it up 3. So this goes up to 3. This goes up to minus 3. And these, of course, are my asymptotic lines. So we go ahead and put those in. So remember how secant looks. So this is secant right here. And so a fourth that distance is our asymptote. Another fourth that distance is where it hits 1 again. But in this case, 1 will be 3 because we've stretched it by 3. Back a fourth our period would be the asymptotic line, and back half our period would be the 1 again, as we have here. So that's what we're doing here. And so when I draw this in, it will come in at 3 and head back out. Comes in, comes up to 3, and then it comes in and comes up to 3. Alright, and so that's how we do these two secant ones. Let's go ahead and do some cosecant. Alright, so this cosecant graph, here we're just going to be stretching it by a half, and so here we're only going to be a half and a half. So this is 1/2, this is minus 1/2. And notice we'll be doing the same over here, so I might as well just write it in. Minus 1/2 and a half. Alright, so the only thing, we write our ones down to halves, and so that's where we're going to mark out. Remember, secant is 1 over sine of x. And so when we flip this, so our period here is 2 pi over 2, so that's just pi. So I'm going to mark out my pi. I'm going to mark out half of that, which would be pi over 2. I'm going to mark out the fourth point, so it would be pi over 4 and 3 pi over 4, or 3 pi over 2, sorry. Nope. I'm losing my mind. That would be 3 pi over 4. Alright, and so here at pi over 2, we're going to have our, so remember sine goes, let me just draw sine in real quick in red. Let me just draw sine in red. So here our sine would come up, go down, go through, and come back. And so the inverse of that, stretched to a half, would come in, go to the half mark, and then come back out. And then come in, go to the half mark, and then come back out. So we have this right here. And so we have this right here, and that's how you'd graph this one. So then we'll do the same here, but the only difference between this one and this one is now I'm moving it pi over 2. But is it pi over 2? No, we really need to pull this out. So we please remember to always have it in this form. So cosecant of 2x plus pi over 4. So now we're going to move this pi over 4. So we take our 0 and we move it pi over 4. So we're going to just take this 0 right here and we're going to shift it over pi over 4. So we'll start this at pi over 4. And then we're going to move a pi from that, so that'd be at 5 pi over 4. Halfway in between would be 3 pi over 4. And so here we'll have our asymptotic line. Here we'll have our asymptotic line. Here we'll have another asymptotic line. Halfway in between that would be pi over 2. And then pi. And so we're just shifting this to the right by pi over 4. Actually, no, I lied. We're moving it to the left by pi over 4 because this is positive. So we haven't drawn anything yet, so I haven't made an error quite yet. So let me just draw in another line. So this is my 0, and then we're going to go backwards since it's minus. Be very careful, like I almost wasn't. See how this is minus. And so we're going to move minus, and so we're going to move to the left pi over 4. So let's go ahead and move to the left pi over 4, minus pi over 4. And now we have everything drawn in, plus a little bit extra for good measure. So once we have all this, it's going to come in. It's going to hit what our A is, which is half, and come back out. And then it's going to come in here at halfway mark and come back out. And then actually for this one, what actually happens is it just repeats itself. So come in and come back out. So here's our 1 period, and here's just an extra one just for measure. And so that's how you graph these. And so these are just a lot, this chapter is just a lot of transformation of graph. Move this here, move this there, move that there. Once you've drawn these graphs a lot of time, you'll get them in your head which one's which. And if you always forget, you can always just default to finding 1 over whatever it is. So 1 over cosine or 1 over sine in order to do this. And then you can go from there. So good luck and take care, my friends.